How's it going, everybody? Josh KI6NAZ. Today we are going to be doing a little bit of a nuts and bolts video. We're going to talk about your ham radio station and keeping it powered, whether it's going to be in your home, in your shack, in your car, or out in the field. So hopefully this is going to answer a lot of questions that I get about power supplies and batteries and all that fun stuff. So let's get started. Now we're going to be going a little bit beyond what we normally do, right? Talking about batteries that you may have in an HT, and we're going to start talking about how to keep it charged, as well as mobile radios, portable HF radios, stuff that you might have that you take in the field, and other radios that you may have like a 7610 or a 7300 that you may have at your home. All right, so the first stop is going to be desktop power supplies. This is a power supply, MFJ makes it. It is the MFJ 4245 MVP. It is a 40 amp power supply. It has power connectors in the front. These are called terminal connectors or banana plug connectors. There is a 12 volt lighter connection, or your 12 volt car plug-in connection. And you note it says 7 amps, 40 amps on the bottom here. This also features Anderson power pole connectors on the back side, and those power pole connectors receive the 40 amps max that this puts out. Note, this is an adjustable power supply that goes from 9 volts up to 15 volts, and I have it right now, which you can see on the meter there, at 13.8 volts. Most ham radio equipment runs off of 13.8 volts, specifically the HF radios that you'd run in your home or in your shack. Case in point, all the radios that you see here, this Microbit X, this KN990, even this amplifier, these all will run off of the 13.8 volts that this puts out, and in fact that's often how I most use it. Another example of this is this other power supply, switching power supply, again like my MFJ that I showed earlier. It has Anderson power poles in the back as well, and that connects to my ICOM 7610 and runs it. In this case, this is just a small 30 amp power supply that is enough amperage to power the 7610 when transmitting at 100 watts, which is what I will often do. Something that is very important to remember is that HF radios, mobile radios, anything that requires a power source, a 12 volt or what we, I've already mentioned, 13.8 volt or 13.5 volt input, requires a certain amperage for them to achieve the power output on transmit that you're likely looking for. In the case of HF radios like the 7300, the Yaesu 991A, or my 7610, they generally require around 20 to 30 amps to get full 100 watt output of the radio. Now, a note on power supplies, there's generally two kinds of power supplies you can buy, a switching power supply and a linear power supply. I have switching power supplies in my shack. They generally are smaller. There are people who will tell you that some switching power supplies are noisy, or they can introduce RF noise into your radio. This is true, but that has largely improved over the years to the point that that is a defect or an unexpected thing that you could get out of a switching power supply. The other side of the house, the linears, they're much larger, they're heavier, they run hotter, and they draw more power. More clean power to your radio, perhaps. That's up for you to decide on what you want to do. I don't really have strong feelings either way, so if you like your linear, that's great. If you like your switching power supply, that's great too. And if you do have a switching power supply that creates a lot of noise, you should probably get that corrected, take it back, return it, or get it repaired. Another fun thing that all hams like is batteries that we use for portable radios. Something that you may have like a handheld will run off of a battery, right? This is a removable battery. This is not surprising to anybody. And you can buy, replacement batteries. Obviously, this is an ICOM battery. But as well, it should be noted that most of these radios have, DC ports on the side here that you can actually pop open and charge directly off of another battery, like this Bioenno. If you had the wherewithal to build a cable or a wire that goes from the power poles connector to this radio, then you'd have the ability to keep that charge in the field as well. Now, interestingly enough, the ICOM 705 has its own internal battery, and I do have a spare battery here. This is the big boy, the big battery. But you can also run the 12 volts off of this Bioenno battery, which is a 6 amp hour battery, into the 705, and that'll actually increase its power output. Or also, you could use power film. This is a power film Power Saver Max or Lightsaver Max that has its own internal battery that does the same thing. 12 volt output, or more specifically 13.5 volt output that you can feed directly into the 705, or potentially your handheld if it accepts 12 volts, more on that later, and to keep it also going in the field. Now, the same rules apply with batteries as you would with a power supply, is providing the correct amperage to put out the correct power that you want to on the radio. And again, this is going to be something that you need to look at the manufacturer of the radio and the manufacturer of the battery in terms of peak amp hour output of the battery. And again, this is something that you're going to have to look up the manufacturer of both of these. Make sure you pull up the manual, the spec sheet for the radio, and make sure you understand what that radio needs to give you the full power output you need. However, it's possible that you just don't want to work with 100 watts. Maybe you want to do 60 watts, and that's fine too if you just want to run it a little bit less power. Again, talking about a 100 watt radio. So you're probably starting to get the idea that you obviously need to give power to your radio, but you may have further questions on how do I do this in a car, or what is the right way to power my radio in a vehicle. Well, you're going to be running off of the battery in your vehicle, and that battery is going to be recharged by the alternator or an inverter setup if you have an electric car or you've got some kind of other system. But the main idea that you need to keep in mind if you want to power your ham radio in a vehicle, even if it's, charging an HT or keeping it topped off, is that you definitely want to use a direct pass to the battery. So figure out a way to go through the firewall. There are plenty of holes usually in a firewall that you can get directly to your battery, and use the positive lead to the positive on the battery. Makes sense. But on the negative lead, there's generally a ground connection, vehicle chassis ground connection, where a lot of wires are going to be screwed into with little terminal connectors. You should tap the negative side of your battery connection for your radio into the chassis ground. If you don't have that, then you can go direct to negative ground, but it's generally suggested that you go to chassis ground. It is at this time that I want to mention fused connectors. Make sure you have fused connectors for all your radios. What you want to do is make sure that you've got a protection circuit or a protection device in play if there's some kind of spike or some kind of issue with the power, that you need that to break before your radio breaks. So always make sure you use the supplied power leads that come from the company. This is the ICOM 705 power lead that you get in the box with the ICOM 705. But your manufacturers will also provide those same fuse connectors for your mobile installs and your base station radios. They will use different types of fuses. Some will be the little glass vials, and some will be the spade type connectors or the blade type connectors, the plastic ones with the two little feet sticking out of it. Make sure you're always deploying a fused connector for your power. You don't want to damage your radio, so make sure that that fuse blows before your radio does. Now, to go back a bit on HTs. HTs can kind of be problematic when it comes to keeping them powered. Some manufacturers, some HTs will not accept 12 volts directly into the radio. And by that I mean on the little power port that usually is on the side of all your major manufacturer radios. Or, Baofeng's, for instance, don't have a plug to charge directly. That's why you got to use that drop-in charger. But guess what? That battery doesn't want you to dump 12 volts, or again 13.5, 13.8, directly onto the battery, and they use a special charger that's designed to step down that voltage to appropriately feed it into those little terminal connectors on the back of the battery. So for you, you're going to need to have a solution. Again, if your radio, your HT in particular, requires a different voltage, you're going to have to get the appropriate step-down converter, and they call them buck converters, that will allow you to bring the voltage into alignment for what your radio expects. Now, good news, there are a myriad of eBay sellers and people online that sell products specifically designed for this function. A lot of them will even be USB capable, so they will charge off of a USB power brick, and it will feed the appropriate voltage into the radio so you can keep it charged. Now, another option, and this is mainly for the HT folks, but we'll talk about other radios as well, is the 12-volt port on battery banks like this guy, this Jackery, or that MFJ that you saw behind me. Those will charge your HT, and they actually sell little battery replacements that slide in. It's a dummy battery that connects directly to the 12-volt connection that you go into the little cigarette lighter or the 12-volt adapter on whatever it is you're using. Those work great. The advantage of those is that you won't damage your battery while keeping your radio in use, and this is great for if you're mobile, you want to be You want to have a mobile station with maybe like a mag mount that you slap on top of your car. Maybe it's a rental car, maybe it's a work vehicle. So you don't want something permanent, so you use the mag mount. And then you just use a little cigarette lighter and a dummy battery on the back of your radio to keep it all charged. Now, a note on these 12-volt connections that you often find in cars. This varies significantly, and the stories that people will tell you, hams will tell you about the horrors of using a cigarette lighter adapter and burning out the wiring in the car is real. There are cars that have substandard or just standard wiring that will not handle the heat that is generated by the amperage draw of your amateur radios in some cases. Some auto manufacturers have much better wiring and they can stand up to a lot more amperage, but you're going to only know that if you talk to people that have the same car that are also hams, or you try this on your own, which always seems kind of like a dangerous proposition. You don't know if it's going to fail, but you're doing it because it's convenient. In a lot of cases, this is going to be okay for temporary applications, temporary operations, but it's not necessarily a final solution, and you should definitely consider the direct connection to the car's battery. To touch back on the Jackery and other devices like this, right, that have that 12-volt plug there, they work good for charging HTs and QRP radios. You can keep them running. Some will introduce noise, which is the bane of all amateur radio's existence. However, they don't provide enough amperage to run most 100-watt stations that you may take out in the field, like the Yaesu 891, likely not getting all the juice it needs to give you that 100-watt output that you're probably looking for. Let's take a pause in this hot power supply talk or power talk to answer a question I get a lot. Hey, Josh, why don't most radio manufacturers just have an AC plug directly in the back of the radio? Well, the reality is that much like a computer that you have at home, that has a power supply. And this is a power supply that I have off of an old 3D printer that the printer stopped working, but the power supply is still good. This is a 12-volt, 30-amp power supply. Could you use this to power ham radio? Yeah, absolutely. But the reason why manufacturers don't include something like this in the box is that it adds cost, it adds weight, and you may not even want to use a power supply. You may not be tapping into an AC line. You might be using a battery system. You may have a home solar solution for your amateur radio setup. That means you now have this bigger radio with a bulky box inside of it, and it may not be something that you desire. So that company basically lost a business or a sale because they went with something that was more form specific for someone that's only ever planning on running on AC. Further, there's likely a lot more work that the manufacturers will have to do in putting a power supply in the box, making sure that it's isolated appropriately and is not introducing RF noise. Just more work that they got to put in. They'd rather the hams take care of that for themselves based off of their own specific needs. Also, there's been a lot of talk of power supplies that look a lot like this. These are kind of what get used in random devices. Sometimes server blades will have power supplies that have been yanked out and they're being sold and they're like $5, $6, $12, whatever. Those actually do put out 12 volts power. Often some of them will go as high as 30 amps or higher in some cases, and you can definitely power your ham radio station with that. Make sure you're buying something that is of an appropriate quality. Some of these less expensive Chinese jobs, not the greatest quality in a power supply, so just make sure if you are going to go down that road, you use fuse connectors, you make sure you're doing all the things to keep your ham radio safe, maybe even keep it away a little bit if it does actually release the smoke or, in worst case scenario, cause a fire. For those that do decide that they want to use batteries as their primary source of power for their amateur radio, there's an important thing they need to keep in mind. They need to consider what the receive draw in amperage is of their radio and the transmit draw of their radio. And then they need to source a battery system that will allow them the longest operating time that they need. And if you're so lucky to live in an area where you can run a couple hundred watts of solar panels on the roof, you're going to run that into your shack into a charge controller, which is the device that prevents the backloading into the solar panel at night, as well as tries to uniformly charge the batteries, at least some do. Then you're going to need to have a battery system that will offset the charge time, the time during peak sunlight, with the battery bank and the amount of time you need to run. Also, how much time when it's dark, if you live in an area where there isn't much sunlight, how do you keep it topped off? All this stuff should be considered when you sit down to pick out a battery solution for your home. That's a bit more of a deep dive than this video is planned to be, but just keep in mind that some batteries cannot be used after a certain voltage. You have to stop, like a sealed lead acid battery. Not many people are using those as much anymore, but guess what? They're still really inexpensive, and so some people still use them. AGM is another battery composition that people use for home solar setups, and they work really well for that. They can be expensive though, and again, you're going to have to spec that out appropriately in amp hours for your draw on your radio. A lot of people now are using Lifepo batteries, which are the lithium iron phosphate batteries. Extremely lightweight, extremely expensive. And if you start getting into 100 amp hours and plus, you're looking at a ton of money. There is a handy calculator that I will link in the description. You go to that website and you type in the power output that you plan on doing with your radio, the receive draw and the current draw transmit power, and then what your battery solution is going to be, how many amp hours it is. And then it'll ask, how often are you transmitting? Are you transmitting 40% of the time, 50% of the time, and receiving the other 50%? That's all a factor you have to consider. And then after telling it how long you want to operate on just that battery, it will tell you how large that battery needs to be to satisfy your needs. We use that calculator a lot when we want to, spec out a battery. This is a 9 amp hour Bioenno that I use for QRP or weekend portable operations where I'm going to be running something like a G90, maybe even turn the amp on for a little bit and run at 100 watts. All that stuff needs to be a consideration, something that you put into the calculator so that you have the right battery on hand to do the job you're looking for. What I like to do, and this is just a little tip from me to you, I keep 2 of these batteries when I go like weekend or holiday portable, and I'm planning on bringing the amplifier or operating a lot. The second battery will always be on the solar panel getting topped off while I deplete the battery that's connected to the radio. And what happens when this dies, I swap out to the one that was on the solar panel, usually when the sun goes down, or just slightly before that, and then I'll swap them out for the next day so that I'm always ready to go and I'm always topped off. Now, I'm going to reference the Lightsaber Max here by PowerFilm Solar again because this solves a lot of problems that people have. Another question I often get, Josh, I'm going to be operating portable, but I want to have a power solution for my radio and potentially bringing a laptop into the field. Well, or a tablet, more a tablet in this case. The PowerFilm Solar has a 12-volt output and a USB output. That USB output, I believe, tops out at 4.5 amps, which is good enough for most tablets and actually really good for my little portable GPD Pocket 2, which I've done a review about. I'll link it in the description so you guys can check out my thoughts on that laptop. But that's really handy, and a lot of charge controllers that involve solar have this capability. They'll have a built-in USB connection for a laptop or a tablet, as well as the 12-volt output you need to connect to your battery or directly to your radio. And we should talk about that too. Going directly to a radio with a solar panel is something you can do. You can do this, but depending on your weather in that particular day, any fluctuations in power are going to be seen on the radio end as well, particularly if it gets like really cloudy really fast. It's generally a good idea that you use a battery in the middle as a bit of a buffer for power so that you get a constant clean supply of battery to your radio. And a charge controller is generally required as a box that sits between the battery and the solar panel to keep it topped up. There's one last power supply I want to mention, and it's this kind. This is a bench power supply. This is something that you're going to use more for kit building, QRP radios, small stuff that you may be playing around with on the workbench. These come in much larger sizes that have greater power output and greater amperage, but this is the one I use. It's just a tiny little tool kit. It's some company I found online. It has a max output of 10 amps, AC 100 watts, DC 200 watts. What this allows you to do is get in there and really fine-tune the voltage that you want. This is now saying 13.5 volts. I appreciate it might be hard to see. And if you click it, you'll now get a red line here, or red text that says 13.5, and then you'll start to see this line that's sweeping across. So this has all kinds of information built in. This particular unit has 2 banana plugs, and it also has an output for USB-C, although you don't need to use that for ham radio. I have this connected to a QRP radio here, so if I start it up, we should see a little dip on information, and it's showing us a draw of 0.11 amps. This is set right now to 2 amps max, and we can see a little line. Hopefully you can see that. I know this is a bit tough, guys. I apologize. Some hams like these because they'll do voltage and current. We can set, of course, a more accurate voltage. We can read the amperage across if we want to adjust or go up or down. And we'll get a nice little reading whenever it's being, used for any amount of time. So it just provides a little bit more control. You can definitely use just a standard switching power supply if you're going to play around with kit radios, but stuff like this is sometimes nice when it calls for a little bit more specific range. And I think I said it pretty quickly. This is a Toolkit RC-P200. Yeah, about 95% efficient as advertised. I haven't tested this, but every time I use it for little kit projects, it does fine. How we power our stations, whatever it is that we're doing in ham radio, is always a lot of fun to me. I spend a lot of time thinking about what I'm going to deploy in the field and just how I'm going to power my own station at home. It's a super fun place that you can go into. Just keep in mind it can start getting really expensive if you're thinking about going full battery at home and you want to just, solar panel top it off. So take your time with it, set a plan, write down what your goal is. I want to operate all weekend, or I just want to do a POTA activation and get the heck out of there. That is going to change what you need and how much you spend in the long run. So lay out a goal and then start building a plan on what you may need to power your shack or your radios when you run in the field. I hope this was helpful to you. Again, I'm Josh KI6NAZ. I would thank you and appreciate so much if you gave me a thumbs up. Consider subscribing if you have not already. I live stream every Saturday at 5 p.m. Pacific Standard Time and every other Wednesday, 6 p.m. Pacific Standard Time, as I am now hosting Ham Nation. Okay, thanks so much for watching. I'll talk to you later. See ya. Now you're thinking to yourself, this is all, again, with that cricket.